Good morning, everybody. Once again, Dr. Salim is here with you guys. Let's discuss some more questions to make our SPI examination for the registry exams. Make it easier. Let me share the screen with you guys and discuss a few more questions to make our exam more easier. Okay, so here is the question. The question is actually asking that what is the normal range of angle for echocardiography, or we can say echocardiographic Doppler studies, if you do. What do you think? What is a good range? Correct. Exactly. C is the correct answer. From 0 to 20. But the best angle will be try to make it 0 degree. Correct. Keep in mind. Okay, next question. If we get Doppler study of common carotid artery with 7 megahertz transducer and our reflected frequency is also 7 megahertz. Now, what type of Doppler shift is achieved? What do you think? If your operating frequency and receiving frequency is the same, what type of Doppler shift do you receive? Absolutely, that is right. No Doppler shift will be received because reflecting frequency minus initial frequency. So we have both of them is the same. So Doppler shift will be 0 in that case. Okay. And process of Doppler effect, which of the following frequencies are selecting Doppler shift? When we put a Doppler shift, it's a positive or negative Doppler shift. So what do you think? Which one will be the dominant? Which one will select the Doppler shift? That this has to be the Doppler shift. If we can tell it, if we can call it as a negative or positive, what do you think? Correct. B is the correct answer. That is the reflective frequency. If we receive more, it's a positive Doppler shift. If we receive less than operating, that's a negative Doppler shift. Correct. Okay, next question. Easy, very simple question. It says if your operating frequency is 8 megahertz and your receiving frequency is 8.1 megahertz. So what do you think? What type of Doppler shift do you receive? Correct. Number one, it's a positive Doppler shift because your reflecting frequency is more than operating frequency. And then B is the correct answer. Positive 0.1 megahertz. That is absolutely the correct answer. Okay, let's do this question. When reflected frequency is lower than the transmitted frequency or initial frequency, what type of Doppler shift is achieved? So what do you think? Which one will be the best answer to receive, to choose or to select? Correct. B is the correct answer. Negative Doppler shift because your reflecting frequency and is actually less than or lower than transmitted. So it means we have a negative Doppler shift. That is correct answer. Let's do next. Okay, this is a lot easy question. Very easy. What is the worst Doppler angle? What do you think? Correct. 90. D is the correct answer, 90 degree. Why? Because with a 90 degree, we get cosine of 90 is 0. And there was no Doppler shift will be achieved with that. What is, okay, let me bring this a little up. All right. Now it says, what is the cosine of 0 degree angulation? What do you think? Absolutely correct. A is the correct answer. Positive 1.0. So it means 1 means 100%. When we're scanning with a 0 degree angulation, you get 100% of Doppler shift. Even a small shift will be achieved. Okay. What is the cosine of 45 degree angle? What do you think? Correct. B is the correct answer. Positive 0.71. That is absolutely correct. Now, the next question is, what is the cosine of 60 degree angle? What do you think? Yes, that is correct. C is the correct answer. Plus 0.5. And that is actually means 50%. Absolutely correct. Let's see this question. What is the cosine of 90 degree? Just I mentioned earlier. What's the cosine of 90 degree? What do you think? Yes, D is the correct answer, 0.00. Because of that, when there's cosine is 0 and we have a Doppler shift angle formula, correct? Equation is that Doppler shift is equal to 2 times operating frequency times velocity of the RBC and times cosine of theta or angle, and everything divided by the propagation speed of sound in a soft tissue. Now, if you look, if angle becomes 0, I mean the cosine becomes 0, so above the denominator, everything will become 0 and there will be no Doppler shift achieved. Okay, what is the cosine of 180 angle? What do you think? So from one side, you go all the way to the other side. Yes, negative 1.0. That is the correct answer. Absolutely correct. Okay, next question. Simple and easy question. It says, commonly, which of the following color is represented for the positive Doppler? Like, which color is internationally, we can say, accepted as a positive Doppler shift? What do you think? Yes, of course, a red color. That is absolutely A is the correct answer. Commonly, which of the following colors or color is selected for the negative Doppler shift? Like we had that one, so same question, but this time it's for the negative Doppler shift. What do you think? Absolutely agree. Blue will be accepted as an internationally that is a negative. That's flow is going away from the frequency, so from the source of flow. Correct. For source of the pulses actually. Okay. Next, which of the following information can be provided with a color Doppler shift? Carefully. Direction of the flow, nature of the flow, speed of the flow, presence or absence of the flow, and all of the above. What do you think? Doppler shift. What do you think? It's a color Doppler. Correct. All of the above is the correct answer. Just give us all these information. That is the speed. We can say that's a mean velocity. It's just the average velocity we get. Okay, next question. Which of the following can be controlled by the operator regarding the color Doppler? If you are doing any study, so which of the following are in your control? You can just control it, or you can just do any addition. You can do anything edit you want to. So is it color box, color scale, color box location, color gain, all of the above? What do you think? Yes, all of the above. All these are operator controllable, correct, inadjustable. Next, which of the following can be controlled by the operator regarding the color Doppler? When you do color Doppler study, what do you think which one is the correct option? It's a color inversion, color box angulation, color wall filtering, baseline shifting, or all of the above. Yes, I will also select all of the above. So all these four options are, we can say, controlled by the operator. So they are controllable or adjustable by the operator. Okay. Few more questions, and then that's it for today. Let me see. Let's do these few questions. Okay. Now, when evaluating slow flow, what is a good color scale to see the flow, to achieve, to visible the flow? If the flow is very slow flow, what you should do? High color scale, low color scale, very high color scale, all of the above, none of the above. To see the flow, what do you think? If the flow is slow. Absolutely correct. Bring your color scale just down, make it down. That is correct. Make it decrease it. All right. Aliasing artifact can be corrected with the following option. What do you think? If there's an aliasing artifact going on in your picture, what do you think what you should do from these options to correct that? Is it shift the baseline down? Is it adjust the PRF? Is it use the low frequency, like one operative frequency, just decrease it? Is it adjust the Doppler angle, or all of the above? What do you think? Yes, I will also select E, which is all of the above. That is the correct answer. Because all these things will adjust, will fix the problem, the aliasing artifact we have, it will adjust it. PRF is pulse repetition frequency. That is like a scale, correct? Okay, next. Aliasing artifact occurs when the system exceeded which of the following? When we get this aliasing artifact, what do you think? Which of the following is happening? Then we will experience that aliasing artifact. What do you think? Is it operating frequency exceeded? Is it negress limit exceeded? Is it increased depth? Is it a slow flow velocity? All of the above. What do you think? Which one is happening from these that we experience aliasing artifact, which is exceeded? Yes, B is the correct answer. When negress limit is exceeded, you have a small room for the scale, but the flow is very high speed flow. So you have to increase your PRF, your negress limit. Negress limit is actually, it's actually here. The question is in the next question. It's already here. So that the In Doppler studies, half of the PRF is called Nyquist limit. So they are the same. So these two questions are very related to each other. So if we increase the Nyquist limit, that half of PRF, if we increase that, then you will have more room for positive Doppler shift and for negative Doppler shift. This way, we will not experience aliasing artifact. That is good. And you know, if it's a color Doppler, the aliasing artifact you will see mix of two colors, you know, different colors like blue and red and all those. That's aliasing. If it's a spectral waveform, so you will see the peak systolic below the baseline actually. So that's how we adjust it. So for this one, also the B is the correct answer, this one. And for this one, we can say half of the PRF is also called Nyquist limit. C is the correct answer. Absolutely correct. Okay, my dear healthcare providers, I'm sure these questions, these explanation, it will help you on your board registry examination, especially ARDMS, American Registry of Diagnostic Medical Sonography, or if you're sitting for any national or international exams, these are the questions they will ask you. So just pay attention several times, watch them, listen to them. You can write your own notes if you want to. And then also, if you did not subscribe the channel, please subscribe it and also share with others, those who really need this type of information. So if they also subscribe the channel, they will get the notification for upcoming more videos. Take care and see you soon.